The topic for our group is application of calculus in economics, and it will contain the following 4 parts. I will share content about producer and consumer surplus. Let's start with a few key concepts. Consumer surplus refers to the difference between the maximum price a consumer is willing to pay for a good or service and the actual price paid, given a certain quantity purchased. It measures the extra satisfaction or economic welfare that consumers gain from transactions. Producer surplus, on the other hand, is the difference between the total revenue received by the producers and their production costs. It reflects the benefit gained by sellers. The sum of consumer surplus and producer surplus is the total social surplus, which represents the overall welfare that market transactions bring to society. It serves as an important indicator of market efficiency and resource allocation. Based on these definitions, for a given quantity of goods, consumer surplus is the difference between the demand function value and the market price. The total consumer surplus is the sum of these discrete differences. Its geometric interpretation is the area between the demand curve and the price line. This is where we apply integral calculus to calculate it. The same logic applies to producer surplus and total social surplus. Now let's look at an example. Assume for a good, its demand curve is 60 over square root x plus 1, and its supply curve is 2 plus 1 over 15 x power of 2. The equilibrium price is 15 and the equilibrium quantity is 14. We want to calculate the consumer surplus, producer surplus, and the total social surplus. So we imply the integral. For the consumer surplus, we also need to use the substitution rule. The integral for the producer surplus is quite easy, and for the social surplus, we just add the two together. This is all for my presentation.
Hi, my name is Xu Zhiyao. My student ID is CST2509050. One of the most important goals of a firm in economics is profit maximization. To determine the level of production that generates the highest profit, calculus plays a very important role. Profit is defined as a firm's total revenue minus its total cost. First, we define 3 basic functions. The cost function, denoted Cx, represents the total cost required to produce X units of the product. The revenue function, denoted Rx, represents the total revenue obtained from selling X units of the product. Therefore, the profit function is Px is equal to Rx minus Cx. Second, the key idea of calculus in this problem lies in the use of derivatives. In economics, derivatives are often interpreted as marginal values. For example, the derivative of the cost function Cx represents the marginal cost, which is additional cost of producing one more unit. Similarly, the derivative of the revenue function Rx represents the marginal revenue. The derivative of the profit function Px represents the marginal profit. When profit reaches its maximum value, the marginal profit is equal to 0. Mathematically, this condition is written as derivative Px is equal to 0. This means producing one more unit or one less unit will both result in decrease in profit. From an economic perspective, this condition can also be explained as the point where marginal revenue equals marginal cost. If marginal revenue is greater than marginal cost, producing more units will increase profit. However, if marginal revenue is less than marginal cost, producing additional units will reduce profit. Therefore, profit is maximized when marginal revenue is equal to marginal cost. In real life, businesses use this method to determine production scale and operating strategies. Whether in manufacturing, retail, or services, profit maximization models help businesses make more rational decisions. In summary, calculus provides a scientific and precise method for solving maximization problems, making economic decisions more effective and reliable. Thank you, Lisa.
Hello, in part 3, we're going to talk about the application of calculus on marginal effect. The core of this application is to use derivatives to deceive the rate of change of economic variables, which means that it can accurately analyze the additional benefit of utility brought by increasing one unit of input or consumption. And here is 3 basic conceptions we need to know when we wanted to solve the problems of marginal effect. And first one is the marginal utility. First, we use UX to represent the total utility obtained from consuming X units of a good. So the first derivative of UX functions is the marginal utility, and it measures the change of the total utility when one unit of the product is consumed. And here is second part is the marginal cost and the marginal revenue. We use CQ to represent the total cost, and we use RQ to represent the total revenue. So the first derivative of CQ is the marginal cost. It can measure the change of the total cost when one unit of the product is changed. And the first derivative of RQ is the marginal revenue. It can measure the change of the total revenue when one unit of the product is changed. And here is the third part, the marginal product. We use QLK function to represent the total output produced with labor input L and the capital input K. So the first derivative of this Q function is the marginal product. So when we assume that the capital input K remained unchanged, these functions can measure the change of total output when one unit of the labor input L is changed. And here is the questions why we can use derivatives to measure the change of output when one unit of input is changed. Here is the reason. This equation is the knowledge we have already learned about the derivative of fx. So when delta x equals to 1, we can know that the delta y equals to derivative of fx multiple 1, which equals to derivative of fx. So this equation tells us that we just can use the derivatives to measure the change of the output when one unit of input is changed. Thank you.
Hello, my name is Zheng Weijia, and my student ID is CST2509067. What I want to talk about today is the application of calculus in the elastic analysis of economics. I will take the operation of a coffee shop as a background. It will show how calculus can be used to solve real economics problems. In a campus coffee shop, pricing is a common problem. As we all know, if the shop raises the price, profit per cup increases, but demand may decrease. If the shop lowers the price, demand increases, but total revenue may fall. The objective of this study is to use price elasticity to find the optimal price. Here we can see the picture. We assume a simple linear demand function, Qp equal to 1000 minus 20p, where Q is the daily demand and P is the price. The price elasticity of demand is defined as ED equals DQ over DP times P over Q. For this model, elasticity depends on the price level. Total revenue is price times quantity, so the revenue function is this one. Rp equal to 1000p minus 20p squared. This is a downward opening parabola. By taking the derivative and setting it equal to 0, we find that revenue is maximized when p equals 25. At this point, the absolute value of elasticity is equal to 1. And in reality, we also need to consider cost. Suppose the unit cost is 5 per cup. The profit function becomes this one. And after taking the derivative, and the optimal profit price is 27.5. At this price, demand is elastic, which means the optimal profit occurs in the elastic region. In conclusion, price elasticity connects calculus with real pricing decisions. Revenue is maximized at unit elasticity, where profit maximization usually occurs in the elastic demand region. This simple model provides clear guidance for pricing strategy, although it also has limitations. Thank you.